Viewers, in this video we will see resistors in series and voltage division. For this we will consider a circuit which has one voltage source and two resistors, namely R1 and R2, both are connected in series. The voltage drop across R1 will be V1 and voltage drop across R2 will be V2. We have noted here. Next, the amount of current flowing through both the resistor will be same, that is I. So how can we define the series connection? So for this we will take out a resistor. This is resistor and it has two terminals. It is a non-polarity device. So we will take one end is starting end and another one is finishing end. Okay. Now we will apply the same to these resistors R1 and R2. Now this is the R1 starting end and this is the R1 finishing end, and this is the R2 starting end and this is R2 finishing end. Now this in this series connection, the supply voltage positive terminal is connected to the R1 starting end and R1 finishing end is connected with the R2 starting end, and finally the R2 finishing end is connected back to the supply voltage negative terminal here. So this type of connection can be called as a series connection. Now in this video we are intended to find out the equivalent resistance of this circuit and the amount of current flowing through these resistors, or the amount of current flowing through this circuit, because the circuit current or the current through the individual resistors will be same. For that we need to apply two laws, that is first one is Ohm's law and second one is Kirchhoff's voltage law. We know that Ohm's law, V is equal to I into R. Okay, this is Ohm's law. And second one is Kirchhoff's law. So to find out the equivalent resistance of this circuit, we need to apply Kirchhoff's voltage law. So Kirchhoff's voltage law stating that in a closed loop circuit, the algebraic sum of the voltages in that closed loop circuit will be equal to 0. So to apply this Kirchhoff's second law in this circuit, we will draw a loop like this and we will mark the arrows like this. Okay. Here in this circuit, three voltages are available, that is V1, V2 and supply voltage V. Okay, this is supply voltage V. Now in this arrow we can draw it in either of the direction. Now I am drawing this direction. This arrow while entering first meeting the positive potential of this V1. So we will take it as V1 is positive. Okay, and further if we proceeding, then this arrow meets V2's positive potential, so we will write V2 is also positive, and while coming back this arrow will meet first the negative terminal of the supply voltage, so we will write supply voltage is negative, which is equal to 0. On further simplification of this equation, if we taking out this minus V to the right hand side of this equation, this will become plus V. So I can write V is equal to V1 plus V2. This is from this equation is the result of Kirchhoff's second law, or the Kirchhoff's voltage law, that is Kirchhoff's voltage law. Okay, from this equation we can say that the summation of voltage drop across individual resistors is equal to the supply voltage. From this equation we will find out the equivalent resistance of this circuit. How? We will apply the Ohm's law here, that is V is equal to I into R. So how we will apply just we'll take that V is equal to the circuit current is I. This is the I amount of current which is flowing in this circuit. Okay. Now this is I into, I don't know the value of equivalent resistance of this circuit. So I will just write R equivalent. So that is the equivalent resistance of this circuit, which is equal to the V1 is the voltage drop across R1. So the amount of current flowing through the R1 will be I1, sorry, correction, I into the value of resistor will be resistance will be R1 plus for this plus we will write the plus, and voltage drop across V2. V2 will be the amount of current flowing through the R2 is also I. So the amount of current is I, and the resistance of the R2 will be R2 resistor will be R2. Now for the simplification, I into R equivalent, we will write this term as it was. Next, on the right hand side we will take out the common term, that is I, and remaining will be R1 plus R2. Now cancel out this I term which is equal on both sides. So the remaining will be R equivalent, which is equal to R1 plus R2. From this equation, we can come to a conclusion that the summation of individual resistance value will give the equivalent resistance of the series circuit. Okay, and one more point we need to note it down here is the equivalent resistance value will be greater than the highest resistance value of the circuit element. Okay, fine. Or this equation we can also write like this, that is summation of A is equal to 1 to N or A. Any number of resistors may be connected in that circuit. Those resistors resistance values summation will provide the equivalent resistance value of the series circuit. Okay, now we need to find out the value of current I. So to find out the value of current I, we will just simplify this circuit by replacing this R1 and R2 resistors by its equivalent resistance. Then we will calculate the value of circuit current. Now we will simplify it. So this is the voltage source as minus terminal. This is the supply voltage. This is R equivalent resistor, and further the other end of the terminal, finishing end of this terminal is connected with the negative terminal of the supply voltage, and the amount of current flowing through this circuit will be I, and from this circuit we can find out the current. We know that as per Ohm's law, I is equal to V by R. So here I is equal to the amount of current flowing through this circuit is I, and supply voltage will be V. So V I can write as it was, and in place of R I will write R equivalent. Okay. Now the R equivalent can be replaced with this two values, that is R1 and R2. So I is equal to V divided by R1 plus R2. So this is the amount of current which is flowing in the circuit. Okay. Further, we need to find out the voltage drop across individual resistors in terms of supply voltage and the resistance value. For that, we need to find out individual individual resistor voltage drops, that is V1 and V2. That is V1 is equal to I into R1. The value of I can be replaced with this value. Okay, so if I am replacing this I with this value, V divided by R1 plus R2 into R1. Now if we making all the resistor values to one side, then we will get R1 divided by R1 plus R2 into V. Okay, further, this is the one term. We have find out the voltage drop across R1, that is V1, in terms of resistance and supply voltage, and V2, that is voltage drop across resistor R2, that is V2. We will now find it out. Okay, that is V2. The amount of current flowing through this through the resistor R2 is I, and resistance value is R2. From this equation, same as the above, we need to replace the value of I with this value, that is V by R1 plus R2, V divided by R1 plus R2 into this value R2. If we moving this resistance value one side, we will get a value, that is R2 divided by R1 plus R2 into V. So the into V. From this equation, these two equations, if we seeing this is the common term, the variation is only R1 and R2. So from this we can come to a conclusion that the individual elements voltage drop will be based on its resistance values only. So in this series connection we need to note 3 points, that is, note, first one is current through all resistors is same. This is only applicable for series connection. Second, the voltage, the supply voltage is equal to individual summation of individual voltages. Individual voltages, individual element voltage drops. Third one is the equivalent resistance value is equal to summation of all resistance. So these 3 points must be kept in mind for the series circuit. These are all the very important points. Thank you.